This is Chapter 5, Unit 2. We're talking about z-scores in this chapter. Notice that a z-score specifies the exact value of a score x within a distribution. A positive z-score means the score is above the mean. A negative z-score means the score is below the mean. And the numerical part of the z-score shows how far the score is from the mean in terms of standard deviations. And this works whether we're talking about a population or a sample. So let's look at the z-score formula for a population. Z is equal to x minus the mean over standard deviation. Well, remember that x minus mean is a deviation score. You know how to calculate those. And then we just take that deviation score and we divide by the standard deviation to find z. So here's an example using population. A distribution of scores has a mean of 100 and a standard deviation of 10. What z-score corresponds to a score of x equals 130? Step 1, make a table. And then if your x value is on the table, I'm not going to require you to draw the normal curve. If it's not, I'd like you to draw the normal curve every time. So here's my table. I listed the z-scores from -3 to +3. I put the mean of 100 in the middle, right below 0. And then because the standard deviation was 10, I counted by tens in order to fill out the rest of the x numbers on my chart. So my question says, what z-score corresponds to a score of x equals 130? Note that 130 is on my table, and I can just read off that it corresponds to a z-score of 3.00. Well, let's use the formula and let's verify our answer. So if we use the formula, we put in 130 minus 100 over 10, we end up with 3.00. Again, this is exactly the same as reading it off the table. So let's look at another example. A distribution of scores has a mean of 86 and a standard deviation of 7. What z-score corresponds to a score of x equals 95? Well, we're going to make a table, and we're going to use the mean of 86 goes right under the 0 of the z-score, and then we count by sevens because the standard deviation is 7. Fill out the x scores. You're going to notice that a score of 95 is not on our table, so go ahead and draw the normal curve as well. So then I want you to draw a line at x equals 95 where it would be on that graph. And then I want you to use the formula to determine the exact z-score. So if we fill in the numbers, we get 95 minus 86 divided by 7. This gives us 1.29. So place an X on the picture where this z-score is located and verify that it makes sense. Well, yes, it does, because in our picture, a score of 95 would be somewhere between 1 and 2 where we placed a line, and yes, 1.29 makes perfect sense. So our answer would be correct. Now let's see how we determine a raw score if we're given a z-score for a population. So we can rearrange the equation. The z is equal to x minus mu over standard deviation. Just cross multiply, rearrange a little bit, and you get x is equal to the mean plus z times the standard deviation. So whenever we're solving for z, we're going to use the z equals equation. However, we're going to use the x equals equation to solve for x, to solve for a mean, or to solve for a standard deviation. It's just much easier because there's no division involved when you use this second equation. So again, z equals, you only use this equation to solve for z. X equals equation, you use it to solve for everything else. So let's determine a raw score x if we're given a z-score for a population. So here's an example. For a distribution with a mean of 60 and a standard deviation of 8, what x value or what score corresponds to a z-score of negative 1.50? Step 1, make your table, draw the curve above it. Again, the mean is 60, so you're going to put the value of 60 on the x row just below the 0 for the z-score, and you're going to count by 8s because the standard deviation is 8, and fill out your table. Well, you're going to notice that a z-score of negative 1.5 is not on the table, So go ahead and draw a line where negative 1.5 would be. It would be halfway between a z-score of negative 1 and negative 2. Next, you're going to solve for x. Use the equation, x is equal to mean plus z times the standard deviation. Plug in the numbers that you know. You end up with x equals 48. Put an x on the graph to verify your answer. Well, does x equal 48 correspond to a z-score of negative 1.5? Look down at the x row. Yep, 48 would be halfway between 44 and 52. Matches perfectly. All right, now we're going to look at the z-score formula for a sample. You notice it's very similar to a population. We're just replacing the letter for mean and standard deviation. And again, keep in mind x minus m is just a deviation score, and we divide that deviation score by s. So let's look at an example of how to determine a raw score from a z-score for a sample. Again, x minus mean over s can be rewritten to give us x equals m plus zs. Same as in a population, you use z equal to solve for z. You use x equal to solve for the score x, the mean, or the standard deviation. Determining a raw score from a z-score for a sample. Example, for a distribution with a mean of 40 and standard deviation of 10, what is a z-score corresponding to a score of x equals 35, and what x value corresponds to a z-score of 2? Step 1, you're going to make a table with the curve. Your table should be made using the mean of 40 and standard deviation of 10. Step 2, you find x equals 35 on the curve. Notice it's not there, so you draw a line at approximately where it would be. Step 3, you solve for z using the equation x minus m over s. You get z equals negative 0.50. Put an x on the graph and verify your answer. It looks good. Exactly 35 would be negative 0.5 for z-score. Notice that a z-score of plus 2 is on the table, and that's the second half of the question. It says what x value corresponds. It corresponds to an x equal to 60. Draw the line and put an x on the line. Verify using the equation x equals m plus zs. And you get 60 as well. Learning check problem 1. Pause the video, see if you can solve. What location in a distribution corresponds to a z-score equals negative 3? Well, you know the negative tells you it's below the mean, and the negative 3 for z actually tells you that it is 3 standard deviations below the mean. Learning check problem 2. Pause the video, solve the problem. So a distribution of scores has a mean of 90 and a standard deviation of 12. What z-score corresponds to a score of x equals 102? Draw your table, draw the chart, fill it all in. I would go ahead and draw the normal curve. You're going to notice 102 is on the table, so you don't have to. Notice that a score of 102 is going to give you a z-score of 1.00. You can verify this with the formula, x minus the mean over standard deviation. Plug in your numbers, you still get 1.00. So that's your answer. All right, learning check problem 3. Pause the video. So for a distribution with a mean of 72 and a standard deviation of 4, what x value corresponds to a z-score of negative 2.00? Again, make the table, make the curve, and you can read right off the table. If you have a z-score of negative 2, that's going to be a score of 64. There's your answer. You should go ahead and draw your line, put your x in for your answer, and I would go ahead and verify it with the equation just to get used to using the equation. X is equal to m plus z times s. Plug in what you know, and you should still get a score of 64.